I just had to let you know you're.
Good day everyone. For today's video, I'm going to solve some problems about our pretest. So we'll start with number 16. A flange coupling ball consists of 8. Good day everyone. For today's video, I'm going to solve some problems about our pretest. Number 16. A flange bolt coupling consists of 8 steel 20 mm diameter steel bolts spaced evenly around a ball circle 300 mm in diameter. If the coupling is subjected to a torque of 15.1 kN, determine the maximum shearing stress in the bolts. We have A. 40,450 kPa, B. 63,320 kPa, C. 40,054 kPa, or letter D. 31,298 kPa. So to solve this, in order to find the right answer, first P is equal to T over N times R. So like the value is 15,100,000, or for the 15.1 kN meter divided by 8 times 150. So we have P is equal to 12,583.33 Newton. So to solve for the maximum shear stress, we have P is equal to maximum shear stress is equal to P divided by pi over 4 D squared. So plug in the values again. 12,583.33 all over pi over 4 times our diameter is 20 squared. So our maximum shear stress now is 40.054 MPa. Or to convert that into kPa, we have 40,054 kPa. So in these choices, our correct answer is the letter C. 40,054 kPa. On to our next problem. A multiple disc clutch of 10 steel discs and 9 bronze discs. The effective outside and inside diameters are 20.32 cm and 15.24 cm respectively. If the axial force or the FA is 540 Newton is applied and the shaft turns at 120 RPM, I mean 1200 RPM, find the horsepower capacity, assume the coefficient friction factor is 0.27. A. The 39.266 horsepower, B. 40.482 horsepower, C. 37.458 horsepower, D. 35.659 horsepower. So to get the correct answer, first we need the solution. So N is equal to N total minus 1. So our N simply 18 because of 10 plus 9, 19 minus 1, 18. So we have Rm, we have G outer diameter plus inner diameter divided by 4. In the value is 20.32 our outer, and the inner diameter is 15.84 divided by 4. So our Rm is simply 8.89 cm or 0.0889 meters. So next, solve for the T. T is equal to N times F times the axial force times Rm. So plug in the values again. Our N is 8, our F is 0.27, our axial force is 540, and our Rm is 0.0889. So we have T is equal to 233.31 Newton meter. So since we have the T, we can also for HP. Our HP formula is equal to 2 pi times the n or the rotation speed times the T divided by the 60 times 746. So plug in the values, we have pi 2 pi 1200 is the RPM or the N, and our T is 233.31 divided by 44,760. So our HP now is 39.226 horsepower. So our correct answer is the letter A, 39.266 horsepower. On to our next problem, problem number 18. An engine develops 40 kilowatt at 1,200 RPM with a single blade clutch with two pairs of friction surfaces transmitting the power. Consider the F is equal to 0.30 and mean diameter of this is to be 200 millimeter. Determine the axial force required to engage the clutch and transmit power. A. 4.832 kilonewton. B. 5.305 kilonewton. C. 3.693 kilonewton. D. 6.922 kilonewton. So, in order to find the correct answer, first we need to solve the solution. So T is equal to P times 60 over 2 pi times N. So plug in the values, 40,000 times 60 divided by 2 pi times the N is equal to 1,100. So we have T is 318 by 31 Newton. So we can also put FA. FA is equal to T over N times F times Rm. So plug in the values. FA is equal to 318.31 divided by 2 times 0.30 times the 0.1. So FA is simply 5.305 kilonewton, or simply the right answer is letter B. So next problem. A cone clutch has an angle of 10 degrees and F of 0.42. Find the action force required if the capacity of the clutch is 7.46 kilowatt at 500 RPM. The mean diameter of the active cylindrical section is 300 millimeter. So A is 0.432 kilonewton. B 0.3927 kilonewton. C 0.2453 kilonewton. D 0.2384 kilonewton. So first, we need to solve for the axial force. So T is equal to 7,460 times 60 divided by 2 pi times 500. So our T now is 142.47 Newton meter. So next, solve for the axial. So axial force is equal to T times the sine alpha over F times the Rm. So by the values, 142.47 times the sine of the 10 degree divided by 0.42 times the 0.15. So we have FA is equal to 392.68, or simply 0.3927 kilonewton. So the correct answer for this problem is the letter B, 0.3927. On to our last problem, number 20. A band brake is installed on a drum rotating at 250 millimeter and a diameter of 900 millimeter. The angle of contact is 1.5 pi rad, and one end of the brake band is fastened to a fixed pin while the other end to the brake arm 150 mm from the fixed pin. The F is equal to 0.25 and the straight brake arm is 1000 mm long and is placed perpendicular to the diameter bisecting the angle of contact. Determine the net belt pull in kilonewton applied at the kilowatt is being observed. So A 4.24, B 3.90, C 4.0, or letter D 3.8. The correct answer is letter A 4.24. And that's all. Thank you.
I just had to let you know you're